Good afternoon, good evening, good morning, wherever you may be, and many people join us from all over the world. My name is Clive Snell. I'm the CEO of Contech Live, and it's my pleasure today to introduce a further event in our Contech Scholarly API series. And today we are going to be talking APIs for Papermill detection. I'm very delighted to introduce Adam Day of ClearSkies. Adam has developed a couple of really fascinating and innovative APIs for use within the scholarly publishing workflow. And he's going to talk all about that, and you'll be able to ask him all sorts of questions and find out a little bit more. The way this works is we're working on Zoom webinar. You are muted, but please do file your questions in the Q&A box as you go along. Adam's going to talk for 22 to 25 minutes, roughly. And then we'll come back together towards the end of our allotted time to go through all those questions and to figure it all out. That's really all you need to do. You need to know from me, apart from we will record the whole process. That'll be available free on the Contech.live website as soon as possible. The remainder is over to Adam.
Okay, great. Thanks, Clive. Thank you for the introduction. Let me just share my screen. Okay. So hopefully you can all see a lovely big picture of an iceberg. So I'll say a little bit, first of all, about how ClearSkies came to be. So I work for Sage Publishing, and I had this idea a couple of years ago for a project, which was to do some analysis on peer review. And the way that analysis would work would be that different publishers would share their data with a neutral third party. That neutral third party would analyze the data and then return analysis to the publishers without the publishers actually having to share data with one another. So I put this idea forward. Sage felt that it wasn't right for Sage just because as a publisher, well, they didn't think that other publishers would want to necessarily share data with them directly. So I said, well, can I do it as a side project myself? And that's how ClearSkies came to be. Fundamentally, ClearSkies is all about this. It's about the the peer review process, okay, which is very familiar to all of us. You know, if you work in publishing or anywhere around academia, you know all about this, right? The paper comes in, gets reviewed by independent experts, gets overseen by an editor, and then what comes out at the end is hopefully a journal full of interesting, exciting science. I believe that this process isn't actually as well understood as we might like to think it is. And also that as we move away from this kind of reader-centric subscription world to an author-centric open access world, peer review becomes much more of like it's a service to authors, right? And it's something that we need to be able to demonstrate to authors the value of that service. Okay, so having the analytics on that is potentially a really valuable thing. Okay, so when I started this, I kind of had a vision for how I thought ClearSkies was going to work. Okay, and it's difficult to know where to start building that vision, because there's a bunch of databases, there's a bunch of data pipelines. Okay, and some of those data pipelines have to be joined together to make them work in concert, and then there's a bunch of computers needed, and then there's some cloud services. There's probably going to be a few different roles, and of course, if you're thinking about roles, you have to think about sexy job titles to give people so that they look cool on LinkedIn. And then, of course, if you're doing a presentation about organizing a business, you absolutely have to have one of these continuous improvement diagrams. And then you think, well, you've got to blend all this stuff together, right? you have to do it in such a way that it's a sustainable process, right? If this looks like a bad business plan, I think you're right. And actually, the conventional wisdom is that you shouldn't really build, a big complex project before serving it to the people who are going to use it. Instead, the conventional wisdom is that you should build a minimum viable product. So it's something that is as simple as possible, that can deliver value to the customer, the person using it, and then learn from that, and then build on that. APIs, I think, are a great candidate for a minimum viable product. So you have an editor, let's say, of a journal, and maybe to use an API, you need to have a colleague who is maybe an IT professional, somebody who works with computers. You might need to bribe them with cookies. That's certainly something you could do. But the API part is really simple, okay? All it is, you send a little bit of data over to a server or a service, and that service sends back a piece of data. Dead simple. That's all there is to it. And certainly from the point of view of an IT professional, somebody who's used to working with APIs, this is a preferred way to deal with a service because it's very fast, efficient, flexible, and very simple. The first API that we built was the article tracker API. Article tracking goes back kind of a long way for me. It was maybe about 10 years ago. So this was me. I wear my hair differently now, but this was me about 10 years ago. I ran a really cool physics journal, and there was this other like competitor physics journal out there, right? And this was run by a bunch of meanies. I'm kidding. They were really nice people who ran this journal. But anyway, I did this project where I just took all the articles that my journal had rejected, right? Searched for them on Google. It took a long time. There were no APIs for this back then. And what I found was that the majority of our rejections were getting published by this competitor. And that made me feel great. It's really great. It's not all Schadenfreude, right? This was actually a really useful insight because this told me that there were things that we were detecting in peer review that they weren't. Okay, flaws in papers that clearly weren't being picked up elsewhere. So that was really a useful insight, I thought. But it goes on from there. In about 2019, I wrote a blog post about automating that process, right? So you don't have to do those Google searches anymore. That blog post was really well received. I got a huge number of views. A lot of people asked me about it. And so I thought, well, I must be onto something here, right? So in 2020, we brought it in-house and did this Sage open source article tracker project. There's a peer-reviewed paper about that in JOS, which I'll include a link at the end. So in 2021, I started doing a bit more work on, well, how can I optimize this, right, to get a really precise tracker, something that can really track things well. And there's a few models that got built around that time, including the fast track model, which is the model that is currently serving in the article tracker API. And this year made it available as an API, but also completed work on what I've been calling the super rat, which I think is the current state of the art in tracking articles. I've been told that it's never a good idea to share all of your performance metrics on machine learning models, but this is basically what the article tracker is doing. If you're not familiar with confusion matrices, what this is saying is that there's this data set that's gone in here. This is actually a bunch of archive preprints, right? And it's checking to see, can it tell where those have been published, okay? So it's a lot like a rejected article from a journal, right? It's just saying we have an article here and we have to match it with a publication record. given about, I think, 3,400 or so of these, 2,700 of them weren't published. Okay, and the model correctly predicted that they weren't published. 700 were published, and the model correctly found those, tracked those articles. There were 3 articles where it tracked the wrong article. So this is a false positive. It's a very, very low false positive rate, where it thought that it found the right article and it hadn't. A lot of the time, actually, this is still okay because it might be that it's a supplementary article, or it might be a say a series article, an article that's got the same title and same metadata, for example, and it's very close. And these are the false negatives where it didn't find something. And that's where an article has changed so much that it's not actually possible to track it. So when you've got a really precise tool like this, there's a lot you can do with that. One of those things has to do with Papermills. If you're not familiar with Papermills, I'll just explain a little bit about how they work. So you have an agent. This isn't like the good kind of agent. It's not like the man from U.N.C.L.E. or like, you know, like a publishing agent, right? It's not like that. Not like that at all. Don't make that mistake. This is a different kind of person. This is a very naughty person indeed. You see, what this Papermill agent does is they will go out and look for someone who can write a fake paper. Okay, so this is maybe, it could be a practicing researcher, could be maybe just a student, somebody who knows how to write a fake paper, and they'll say, hey, you know, I'll give you some money, you give me a fake paper. Okay, so they buy the fake paper off. Then they go out looking for someone who wants to be an author. Okay, and they say maybe this person has some incentive to be to author a paper. Like they might be, excuse me, they might need to get published for their career advancement. Okay, or they might maybe not have very good written English for example. So they might not know how to write a paper, but they might have to. And so the agent sells them an authorship slot on that paper, and then the agent will try and get the paper published in a journal. Now, this used to be quite a small problem. There's almost like a little kind of weird curiosity, like this thing that seems to happen somewhere, right? In recent years, this has got a lot worse. There's been a lot more of this going on. This is a really simplistic model, and the like obviously, but the reality is that this happens in a kind of a network effect in very large numbers of people involved in this, and it also happens at scale in organizations that actually do this industrially and produce a lot of fake papers at a very high rate. And it's a big problem because the papers are getting to be more convincing, and there are a lot of them. Now, something about this that might not be completely obvious is that in order to get that paper published quickly enough, the agent basically has to, I mean, really has to, submit that paper to more than one journal. So if you're using a precise article tracker, like the ClearSkies article tracker, and you have rejected some papers, you can track them, see where they went. And sometimes you will find that one of them, or maybe more than one of them, were under consideration at the journal that published them at the same time as they were under the journal, under consideration by yourself. Okay, and this is actually a really good, solid smoking gun piece of misconduct detection, because duplicate submission, which is what that's called, is a form of misconduct. It's very easy to detect with this tool. The problem here, of course, is that while getting these detections after publication is very useful and interesting, it would be much better to get them before publication, right? That would be the ideal. And so that was why we built the Papermill alarm. Okay, and this is a quite different API. So I'll say a bit about how this was put together. So this is PubMed. This might not look like PubMed, but this is PubMed. And there are a bunch of things here that you would recognize if you knew exactly what these were. Like this big cluster here, this is clinical medicine. So a lot of like cancer research kind of comes up over here. I like this one. This is this sort of split cluster with two halves. One half of them is papers about experiments on mice, and the other half is papers about experiments on rats. So you can see that this all kind of fits in a kind of structured way. If you've been following the news on paper mills, then these two names probably seem quite familiar. So both of these people, Smucklide and Elizabeth Bick, have taken their own time, and they've gone through papers in PubMed and elsewhere to find papers that appear to have research integrity issues. Okay, and a lot of them are papers from paper mills. And if you put them onto this map, you find that they're kind of localized, right? There's particular places where they go. And coming from a machine learning background, I'm looking at this thinking, great, you could just build a classifier on this and then you're done, you can detect them all. Unfortunately, if you do that, it doesn't work. And the problem is really just that we have only a very limited number here of the actual cases. So what I did was build this kind of training method where, or actually a method of building the training set where you start kind of searching through PubMed, right? And you're looking for unusual features in the data. And as you're going through PubMed, if you keep finding these articles that Smucklide has put in his lists, then you keep going, right? If you stop finding them, you stop. And that starts to give you this big data set. You end up having to do a ton of manual labeling, which if you've done manual labeling on a problem like this before, you'll know is not a fun thing to do. But the outcome was a classifier that actually was very good at finding those articles. Okay, so we got two APIs. Got the article tracker, we got the Papermill alarm. Both of those APIs are on Rapid API. So if you want to use them, you can just go to Rapid API, and Rapid API includes some instructions for how to use the APIs. Also includes code for making requests to those APIs in multiple languages. Whatever your preferred coding language is, there will be code in there already that you can just use. I put out a couple of Jupyter notebooks which kind of show how you might want to do an analytics project using the APIs. It's the kind of thing that I would do as a data scientist. So just sort of run through a couple of things from those notebooks. So here's an example of some code to just go and take a bunch of archive preprints, right, and drop them into the Papermill alarm and see what you get. And funnily enough, you don't find anything, right? They're all green, right? Green alert means nothing, right? There's no problem here. Actually, that's what we expect to find, right? That's a good result because archive is very separate to PubMed, okay? And so if something is out of domain like that, you shouldn't be able to predict what the result will be, okay? So archive is out of domain for this API. As it turns out, it does actually show us what we expect, which is good. Now, if we want to see, does it detect what we want it to detect? Then what we can do is just take a bunch of the retractions from Smucklide's lists. Okay, so they're just picked out from the list that Smucklide has shared. And there's about 31 of them here. And the result is that 30 of them come up as a red alert, which means this is very similar to something that's been flagged in the past. And one of them comes up as an orange alert, which means it's not super similar, but still worth paying attention to. In case you really want to know all the kind of nerdy details about how these perform, the article tracker API is based on the Crossref public API. Okay, so speed is dependent on that API. If that API is slow, the article tracker is slow. But the best result is up to 500 articles a minute, which is obviously very fast. Best accuracy is about 0.977 F1 score, which is, you could think of that as being about 98% accurate. The super rat, which I mentioned earlier, it's not serving at the moment, but that's 99.5% accurate, which is really as good as I think you can really get there. The Papermill alarm is entirely serverless. So that means that, for example, if you were to make parallel requests to it, it would just spawn new processes and give you as much as you're asking for at whatever speed you're asking for. But if you just do articles one at a time with it, then you get something like 1 or 2 articles per second on average. One thing that I did do with that data set, it's very difficult to measure accuracy with a tool like that because you don't have labeled data for all of the Papermill papers out there in PubMed. Okay, so accuracy is very hard to measure. Precision is hard to measure, but you can measure recall. And what recall is like saying how many of the things that you expect to find do you find. And so what I did was kept 93 of those articles from SmartCollides's lists aside. The model never saw them during training, and then check to see whether it would flag them. And it flagged 91 out of 93. So again, that's about a 98% recall rate. The response has been great. Several publishers interested in using the Papermill alarm. A few of them already are using the API. There's also been some collaboration discussions, different people doing research integrity services, interested in, can they, for example, integrate the APIs? And then people who are doing research on Papermills, also interested in how they can use the tools to help with their research. And there's been some news coverage. This very nice news article in Nature News a few weeks ago. So one of the main sort of pieces of feedback, though, has been about, what if you don't know how to use an API? Okay, so a lot of people working in, say, an editorial role in a publishing house, they might not have experience of working with APIs. So that could be a very new thing for them. So this is one of the nice things about an API as a minimum viable product, right? As I said, it's something you can kind of build on. So one thing that we offer now is that, so if you can't use an API, we have this standard report, right? And the standard report will give you the outputs of these APIs. And those can kind of be combined in a way to give you that report. One thing about this is that if you are doing a research integrity project, or you have a method for research integrity, you need to be very, very careful about how you share that. So these two things were picked very carefully out of a number of things that you can do to detect Papermills, because they are fairly non-sensitive. It's quite hard to work around these tools, and actually the workarounds that might exist are themselves detectable. So these are safe, right? These are good things to have out there. The one really great thing about the standard report, though, is that there's a bunch of other things that fit into detection pipelines that can't be made publicly available, but can be part of the standard report. And what that gives us is essentially the best Papermill detection tool that exists now. So there are a few things to consider there, right? Are APIs the right thing for research integrity? Okay, because as I've said, there are these great pros, right? And especially from the perspective of an IT professional, APIs are simple, they're efficient, flexible, right? You can do a lot with them. But then there's these considerations, right? Things like that skills barrier to use, right? If you're not used to using APIs, they're difficult to use. So we've worked around that by having the standard report there that can help people who don't have the who don't know how to use the APIs. then there's that whack-a-mole problem, right? Which is where if you put a method out there and people learn that the method is in use, then they learn how to work around the method, then you might deal with the problem in one place, but then it pops up somewhere else and you have to find a way to deal with it there. As I've said, these APIs were chosen specifically because they do fit with that, with the purpose of not being easily worked around. So these two are okay, but I think there's definitely stuff to think about there, and it's definitely, this is one of the things that certainly has come back in feedback. It's are these issues with having this stuff out there, and there are definitely things that have been thought through in some depth. So in summing up, APIs, they're a really nice way to do a minimum viable product. They're efficient, they're flexible. We can also use the API to demonstrate value. Okay, so for people who maybe don't know how to use an API themselves, you can still say, we've got this Jupyter notebook. Okay, we've got these ways that we can show you the value by running the API ourselves and showing you the outcome. It's also great as a building block, for whatever other services you want to build on top of that, like the standard report. Okay, thank you all very much. A few references here. I can share these slides on request. These are just some of the things that I mentioned during the presentation. Thank you.
Thank you, Adam. That's terrific. Very interesting, fascinating stuff. I got a couple of questions I'd like to throw at you.
Sure.
When you say make sort of statement that APIs could be good for research integrity tools, but they may not be. If they're not, I'm not an expert in this field. What other things are there for research integrity that would be maybe competitive or complementary or substitutes?
So I think that the ideal is that sorry, should I stop sharing my screen?
I think you have. It's fine.
Oh, okay. So the ideal is, I mentioned that there's these two different ways to sort of train a model, right? And for example, the article tracker is trained for precision, and what that means is that it has a low false positive rate. Okay, so it means it won't find some stuff, but the idea is that the stuff it does find is very accurate. Okay, and that's the right thing to do for that tool. But that is for tracking articles, and it wasn't intended initially for a research integrity problem. A research integrity problem, it makes much more sense to have high recall. Okay, so that means that what you're doing is you're going to find a bunch of stuff that aren't problematic, as well as maximizing, and in doing so, you maximize the stuff that you can find that is. So that's obviously a big problem, right? Because if your automated method finds a lot of stuff that isn't problematic, well, what if that leads to retractions, right? And what if that means that an author who's written a perfectly good paper ends up having a paper retracted just because the method has that false positive rate? So the ideal is that you combine that high recall method with human oversight, which is where you have an individual who can say, okay, these are the cases we need to look at, and really we're sure that all the bad ones are in here, so we just look at these, and then we check to make sure that to pick out those ones that might be the false positives.
Yeah,
that's a really good way to combine the two things, is high recall and the human. If you don't have the human there, you have to have low recall. You have to have high precision, so you don't have the false positives, and then you lose the true positives. So that's the good way to fit them together.
That's interesting. I mean, we've had a lot of context sessions where we've talked about artificial intelligence. Yeah, maybe, but what we're really after is augmented intelligence, and that's kind of, I think, what you were talking about there.
I agree. Yeah.
Just to, I think we have a very broad audience, and I'd like to sort of, well, firstly point out, I'm pretty sure that your article that you picked out, the Springer article, I think that got picked up by some of the national press here in the UK. I think this is not a small issue, and it certainly isn't going to go away. And in that context, looking at a big picture, I like big pictures. What you talked about the naughty guy in the middle, and the agent. This, what are their incentives? What is driving this development? This quite disturbing development.
Yeah. I mean, there's a lot to it, and actually, to some degree, I can't speak to the motivations of individuals who I don't know, but certainly a big incentive is it's to do with publication incentives. So if, let's say, for example, you need to qualify to get a degree or maybe to become a doctor, you might have a requirement that you publish a paper, right? You can imagine trying to qualify to become a doctor. It's pretty intensive, right? You have to work really hard for that.
Yeah.
And so if you have the option of, well, I just pay a few grand to get this thing ticked off the list, which might not even seem relevant to being a doctor, that might encourage some people to do it. Then I think there's possibly just the pervasive culture now of doing this kind of thing, because you can imagine being the one person in your department who isn't just paying for papers instead of doing the work. You're at a disadvantage. You can't publish as much work, and it's much harder to do your job than the people you're competing with. So I think there's a lot of reasons, and I can't say that I know all of them, but I think that for the people who are paying to get their name on papers, it's stuff like that.
Yeah.
As for the people who are selling them, it's money.
Yeah, of course, as is often the case. We have got a question from Jana Christopher, who says, I believe this could be integrated into standard MS tracking systems like ScholarOne or EJP, so that the tool becomes workable for an editorial office. Could you please talk about that briefly?
It's certainly come up, and I think certainly these tools possibly could fit that way, and maybe some other tools as well. As I've said about exposing data, we need to be really, really careful about that. There's other conversations that I've had where there's this idea that's come up, which is like ideally, not necessarily in every case, but ideally you have like editorial. An editorial is based on the assumption that the paper that is in front of them is someone's honest work, okay? And if you don't make that assumption, peer review becomes impossible, right? Because you have to check everything and you can't take anything on good faith. So the ideal is that if you're doing peer review, you don't have any research integrity questions to worry about. You're obviously aware of the issues and you're still looking out for stuff, but it's not like the editorial job. So that a nice, convenient thing would be to have research integrity somewhere else. And so like the research integrity tools fit into whatever workflow those people use, and it's a different thing. But that's one consideration. I think on the face of it, Jana is absolutely right. If this can just be in someone's workflow, that's the ideal. It's quick, it's easy, and it's obvious.
Yep, for sure. Thank you very much for that. Just to jump back again to this big picture issue of once you've identified a fake paper, and you've got a research integrity issue, obviously that gets discarded and is sort of taken out of the equation. But is there any further action taken against the perpetrators?
It really depends. It depends on a publisher's own particular practices. It depends on things like COPE guidelines, which most or all publishers are signatories to. I think certainly speaking from the point of view of a former journal editor, if I had found a fake paper coming into my journal, I would have been livid. I would have been very
I can believe that.
upset about that, and I would have I would have wanted to do something about that. But I think it really does depend on the particular journal, the particular ethical guidelines that are at play, and what is practical as well.
Yeah. Just to finish off, you've obviously you said there's been some interest, and you've said people come and play with the APIs. Where are you at with it at the moment? I mean, what's the status? How many people are using it? How widely accepted is it? That sort of thing. Just very briefly.
So it's in terms of people using the particularly Papermill alarm, it's maybe a few dozen people have used it so far. As for using the data from it, a lot of the conversations have been with people who have not been able to use the API. And so it's either been, say, I've done a few sort of once-offs where I kind of will do a piece of analysis and say, well, here's the output from the API, so I can still demonstrate it, but those conversations have moved much more towards towards a standard report and doing this as a service that doesn't necessarily require someone to access the API directly.
Interesting, very interesting. Adam, thank you so much. We will draw this excellent session to a close. Just to tell everyone, just to reiterate to everyone, the full session will be has been recorded and will be available on the Contact.live website. I would think within 24 hours, hopefully, he says. Hopefully I haven't upset anyone by saying that. Just also to flag up that our main event, Contech, is in just 12 days' time. And apart from the fact that obviously I want to shout about that, Adam's actually speaking at Contech with a colleague, and his session there is called Searching for Research Fraud in Open Alex with Graph Data Science, which obviously there's a theme emerging here, and I think that would be a very interesting session. Obviously, we'd love to see as many of you as possible to come along. We're still taking registrations. You can go online and visit us that way, or you can actually join us at the Marriott and Regent's Park. And who doesn't want to come to London just before Christmas? So do take a look, contact.live. We hope also we might, at the event itself, be saying something more about how we develop this whole series of API meetings, all of which are available to a view on the current website. It does seem to be an area of particular interest in the technology and content world, which is where we are deeply focused. Finally, thanks, Adam, once more for a great presentation. We look forward to seeing you in a couple of weeks. Thanks everyone for attending. Enjoy the rest of your day, wherever you are in that day, and we'll see you next time. Goodbye.
Thanks, Clive. Thanks, everyone. Bye.